Imagine opening your drive and realizing your files are just gone. Most recovery tools will either fail or show your files and then ask for $60 a month to get them back. But it doesn't have to end that way. Today, we're looking at DMDE, DM Disk Editor and Data Recovery Software. Now, don't let the technical name scare you off. In reality, recovering files takes just 3 steps: select drive, scan, recover. And in this video, we'll show you exactly how to do it. Let's start with the most common case, recovering deleted files, case 1. We launch DMDE as administrator, and the first thing we see is the Select Device window. Here's what matters: logical disk, your usual C or D drive, to recover removed files from healthy volumes; physical device, for lost, formatted, corrupted, inaccessible volumes. For example, we lost some files from our D drive. Let's choose it, then click Open Volume and run either a quick scan or a full volume scan. Then all that is left is to select the files and folders you want to restore, click Recover, and save them to a different drive. For example, an external drive. And voila, our files have been recovered. Tip: never save recovered files back to the same drive you're scanning, because this can overwrite the data you're trying to save. For those of you checking out the free edition, keep in mind that it's incredibly generous, allowing you to recover up to 4,000 files from a single folder at a time, with unlimited repetitions. Having started with the basics, let's get into a more complex case. To get the best results, we always launch DMDE as administrator. Once you open it up, you'll see the Select Device window. It's important to understand the difference here. Physical devices represent your actual hardware, like the whole 1 terabyte Western Digital drive, while logical disks are your partitions, like your C or D drive. If your partition has gone missing or the drive says it needs formatting, our tip is always to select the physical device. This allows DMDE to look past the surface and find data that the operating system has completely forgotten about. Next, after target drive opening, we select the required volume and click Open Volume to do a quick scan. Alternatively, if we want to find additional volumes, we run full scan. As the scan runs, you'll see the progress bar moving along. We like how it shows you file signatures and file system structures, like NTFS or XFAT, being found in real time. A great pro tip for your workflow: if you're working on a large drive, you can save the scan log. This means if you need to take a break or restart your PC, you can simply load that scan later instead of waiting hours for a rescan. Once that scan finishes, we're looking at the volumes list. You'll notice some volumes have colored bars next to them. These are the indicator bars and number of files. We always look for the volume with the highest indicator bars because that shows the healthiest file system structure. After selecting it, we click Open Volume. This is where a standout feature comes in: Virtual FS Reconstruction. This essentially rebuilds the directory tree in the software's memory that allows us to see the files and folders exactly as they were laid out before they were deleted or lost. Finally, we navigate the folders just like we're using a standard file explorer. When we find what we need, we right-click the file and select Recover. The Recover dialog will pop up, and here is a crucial rule we live by: never save your recovered files back to the same drive you're currently scanning. If you do, you risk overwriting the very data you're trying to save. Moving along to more complex scenarios, sometimes it's not just a single drive that fails, but an entire RAID array. This usually happens when a hardware RAID controller dies, which leaves the physical disks healthy but the data inaccessible. First, we connect all the individual hard drives from that RAID array directly to the PC. Once they're showing up, we go to the Disk menu and select Construct RAID. This opens a workspace where we can click Add and bring in each physical drive. Then we choose the RAID type, whether it's RAID 0, RAID 5, or others. Now, if you're like most people and you don't remember the specific stripe size or disk order, don't worry. We recommend using the Auto Calculate button. DMDE will statistically analyze the data blocks to figure out the parameters for you. Once the configuration looks right, we click OK, and DMDE creates a virtual RAID device. From there, we can treat that virtual device just like a regular hard drive and run a full scan to pull the data off. In addition to recovery, we often deal with drives that are physically dying. Maybe they're making a clicking sound or just acting very sluggish. To fix that, we start by going to Tools and then Copy Sectors. We select the failing drive as the source and a healthy drive of equal or larger size as the destination. Before hitting Start, we click the Parameters button to set the rules. We usually set retries to 0 initially. This tells the drive to grab all the easy data first without stressing the drive head on broken areas. Another smart move is setting the jump on error to skip 32 or 64 sectors, because this prevents the drive from getting stuck on a physical scratch and potentially burning out. If the drive is failing specifically at the start of the disk, we use the reverse copy to start from the end and work backwards. Just like the scan, you can use a log file to stop and resume this process, which is a lifesaver for long cloning jobs. Now for the pro-level side of things, we have the disk editor. This is where we can manually edit sectors at the hexadecimal level. To get there, we select an object and click Editor. Using the View menu, we can switch between the raw hexadecimal view and the template view. The template view is fantastic because it labels NTFS or FAT structures, making it much easier to read the labels of your data. While we can click on any hex value and type in a new one, remember that edits are in read-only mode by default. To actually save changes, we have to go to Edit, Allow Write, and then Edit, Write Changes. We have to give a stern warning here. Manual hex editing is powerful, but one wrong byte can permanently destroy your data, so proceed with extreme caution. In the end, we believe DMDE is the most cost-effective, high-success tool available today. It outperforms expensive competitors by using specialized algorithms for complex cases, all for a low one-time purchase price with no subscriptions. No matter if you're using the free edition for 4,000 files or the professional edition for its lifetime portable key, it's a must-have. DMDE hits a very rare balance, simple enough for beginners, powerful enough for professionals, and priced without subscription traps. Download DMDE today and get your data back the right way. Check out the description below to get the download link. Try it out and share your experience in the comments. Thanks for watching. Like, share, and subscribe to get more videos like this.